All right, we got section 4.3, inductive reasoning. Inductive reasoning is reasoning based on patterns you observe. We're going to look at some examples here. So example 1, looking for a pattern, what are the next two terms in the sequence? So hopefully you can see here, to get from one number to the next, it's times 4, times 4, times 4. So the next number is going to be 64 times 4, which is 256. And the next number after that is 256 times 4, which is 1024. Number 2, we're supposed to find the next two terms in the sequence. This is the first term, second term, third term. So every one of these terms has a circle. The first one is a triangle. It's got 3 sides. The next one is a square. It's got 4 sides. And a pentagon, it's got 5 sides. So I'm guessing the next one is going to be a hexagon, which has 6 sides. And the one after that is going to be a septagon, not a decepticon, but a septagon, which has got 7 sides. A little harder to draw. 1, 2, 3, 4, 5, 6, 7. Number 3, we got a circle in the first term, and the second one there's a little circle inside the circle, and the third one there's a little circle inside that circle. So the fourth one, I'll try to trace over this. We got the circle, and then this circle, and then this circle. So the fourth one's going to be like that, and then have another little circle inside of it. And the fifth one is going to be like that, with another tiny little circle inside of that, which I'm getting really tiny at this point. Inductive reasoning, looking at patterns and then trying to base things off of that. Number 4, if you look at these terms, just numbering the terms, in this case we're supposed to find the 6th and 7th term. From 16 to 8, multiply by half. From 8 to 4, multiply by half. From 4 to 2, multiply by half. From 2 to 1, multiply by a half. So the next one's going to be 1 times a half, which is a half. If you multiply 1/2 times 1/2, when you multiply 2 fractions, you multiply the top numbers together and the bottoms. 1 times 1 is 1. 2 times 2 is 4. Continuing with our notes. Once we are pretty sure we understand a pattern, we can start to make conjectures. Conjectures, dramatic pause, are conclusions made using inductive reasoning. So let's try and figure out a pattern in this next figure. So first figure has 1 dot. Second figure has 4 dots. Third figure has 9 dots. Fourth figure has 16 dots. So instead of us doing the next 2 terms, we want to find the 20th one. We don't want to draw the next 16 pictures. We want to make a conjecture and do this quickly. So if you look, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So whatever term you're on, you square it, and I'm sorry, I wrote 3 cubed and 4 to the 4th, I meant squared. So when we want to find the 20th term, we just have to square it. So that's going to be 400. We don't need to draw that because that would take quite a lot of time. Next one, try to figure out the 43rd term in the following sequence. A-E-I-O-U, A-E-I-O-U, A-E-I-O-U. Just keeps going the same pattern of the vowels in the English language. Maybe there are vowels in other languages too. I don't know. I'm not a language expert. So the first term, second term, third term, fourth term, fifth term, this repeats. 6th term, 7th term, 8th term. Whoops. And then 10th term. I'm saying one thing and writing something else. So it's the same 5 letters in the same order. So since there are 43 of these, and the pattern has 5 in each. We can take 43 and divide it by 5. It goes 8 times. We have a remainder of 3, which means we're going to have 8 groups of these 5. When we get to the 9th group, we're going to pick the first, second, third one, since the remainder is 3, and that's going to tell us which term the 43rd is going to be. So in this case, the 43rd term is going to be I. Counterexample. We talked about this for a hot minute a while ago. Sadly, not all conjectures will be true. All you need to do is to find one example when it's not true. So a general thing that we do in math, to be true, it has to be true 100% of the time and twice on holidays. To be false, only has to be false one time. A counterexample is an example that shows that the conjecture is false. Example, give a counterexample for each of the false conjectures given. If the name of a month starts with a J, it is a summer month. Does every month that starts with a J a summer month? Absolutely not. So our counterexample has to make this part true and it has to make this part false. So January is a counterexample. January starts with a J, but is not a summer month. Boom. Multiplying a number by 2 makes it bigger. Was that a true statement? It is lots of times, but it's not true every time. Check this out. If I take negative 3 times 2, we get negative 6. We multiplied a number by 2, negative 3, and we got a number that was smaller, negative 6. This next one, if you teach flipped mastery geometry, you are super good looking. Can you think of a person who teaches geometry that is not super good looking? I can't either. So let's just imagine a fictional world in which your geometry teacher was not super good looking. We'll go with Mr. Uglyhead. He's certainly not super good looking. Conditional statements. Conditional statements are extremely useful in reasoning. A conditional statement is a statement that can be written in if-then form. Can be. It doesn't have to be, but it can be in if-then form. If it is in if-then form, it's going to be very easy to do. If it's not, it's going to be a little more challenging. So example 1. If you complete this entire packet on your own, then you will pass the mastery check. This is an example of a conditional statement. The part that comes after the if and before the then, that is called the hypothesis. If you want to have fun with it, then say hypothesis. You will pass the mastery check. Whatever comes after the then, that is called the conclusion. Next example. If you drink coffee late at night, you will have trouble sleeping. This one doesn't say then, but we could throw one in there to make this more obvious. You will have trouble sleeping is the conclusion. You drink coffee late at night is the hypothesis. Please note, hypothesis and conclusion never include the words if or then. Never. Never. Number 3, when Solly wakes up late, it is to catch Santa Claus. That is a conditional statement, but it's not an if-then form. It's going to be easy for us to look at this if it is an if-then form. So let's change it. If Sully stays up late, then It's to catch Santa. So for this, Sully stays up late is the hypothesis. It's to catch Santa is the conclusion. Number 4, dolphins are mammals. Let's write her an if-then form. If an animal is a dolphin. By the way, I was watching the Miami Dolphins this weekend, and the announcer kept calling them the fish. And I was getting super annoyed because they're not fish. If an animal is a dolphin, then it is a mammal. An animal is a dolphin is the hypothesis. It is a mammal is the conclusion. Hypothesis, conclusion. Number 5, write each statement as a conditional statement. Try this on your own, pause the video, and then check to see if your answers are right. Beep. Beep. Quadrilaterals have 4 sides. If a polygon is a quadrilateral, then it has 4 sides. Number 6, parallel lines never intersect. If 2 lines are parallel, then they never intersect. Excellent. Each conditional statement can be broken down to an if part and a then part. The part that comes after the if, once again, is called the hypothesis. The part that comes after the then is called the conclusion. We say that when the hypothesis is true, it implies the condition is also, or the conclusion is also true. So if the hypothesis happens, the conclusion has to. Number 9, identify the hypothesis and conclusion of the conditional. If Solly shoots the ball, then the shot will be an air ball. Solly shoots the ball is the hypothesis. The shot will be an air ball is the conclusion. Number 10, if a triangle is equilateral, hypothesis comes after the if, then it is also isosceles. Never include the words if or then in the hypothesis or the conclusion. All right, almost finished. If we have a conditional statement, there are several related statements we can make. Negation, the opposite of the statement, usually said not P or not P. This symbol means not. Let us use the following conditional to help illustrate the next examples. If I studied really hard, then I earned an A on the test. We can sum up this entire hypothesis with a P. That implies the entire conclusion of a Q. P implies Q. Converse, take the conditional and switch the hypothesis and the conclusion. So we took the Q and put it here and took the P and put it here. If I earned an A on the test, then I studied really hard. So in this case, we had Q implies P. Q's at the beginning, P's at the end. Inverse. Take a conditional and negate both the hypothesis and the conclusion. So the P's and Q's are in the same order, but there's going to be some nots. If I didn't study really hard, and the original said if I did study hard, then I didn't earn an A on the test. So this here is not P, and that implies not Q. Contrapositive. Take a conditional and switch and negate both the hypothesis and the conclusion. So this is not Q, and that implies not P. If I didn't earn an A on the test, then I didn't study really hard. The contrapositive will always have the same truth value as the original. So if the original is true, contrapositive is true. If the original is false, contrapositive is false. The converse and inverse might have the same truth value, but it might not have the same truth value. So here's a summary of the conditional statements, the converse, inverse, contrapositive. Take a look at those. Your homework is section 4.3.